Hello, our project is the ASU e-commerce web service, and our group members are Leon Wong, Trong Vu, Rogelio Barcenas, Dakota Bolt, and Gligor Bodos. For our presentation, we will cover the following: the introduction and background, major requirements, the overview and the overview diagram, the use case diagram, homepage after a user logs in example, user story, our timeline, and then finally future plans. Introduction and background. Trying to buy or sell items locally to other students safely can be difficult. However, our project would address the issue as an e-commerce website. Our website would also offer its web services to students who have successfully registered with our website so that they can create their own custom e-commerce website. Ensuring a safe online experience through a website would be top priority, so encrypting user passwords would be one of our website security mechanisms that protect user account in case our database got compromised. Deployment of our e-commerce website would be done via WebStrar, and our database would be implemented in XML because of its compatibility with WebStrar. Our database would also be using a payment service, PayPal or similar, to handle transactions. The objective of this project is to create a user-friendly web service that students could use to buy or sell items with relative ease. The items the students can buy or sell would include books, shirts, and sports equipment. Students would sign up for the website with their ASU email address and be able to list various things that they would like to buy or sell. The project would be a collaborative effort requiring agile team methodologies to ensure participation among each group member during developmental phases. Each member would also gain teamwork experience, improve written and verbal communication skills, and experience using MVC architecture in the development of a real-world application.
Our e-commerce website and web services requires users to abide by a few requirements in order to be able to use them successfully. The first is that a user must be an ASU student with a valid @asu.edu email address. They must also have a PayPal account or a valid credit or debit card for online transactional use. Users must be at least 18 years of age or older if they are going to use our services. They must agree to our site's terms and conditions as well. If users are going to use our e-commerce web services, they will need to read our documentation on them in order to be able to understand the various specifications that they have, such as input parameters. Lastly, they will need internet access and a compatible internet browser to view and interact with our site and services.
For our overview, developing our web service required deep understanding of how e-commerce transactions worked. Our e-commerce website development requirements dictated that our website be designed and created using web services. This design allows other users to call our web services and exchange information and conduct e-commerce business on their personal e-commerce website. From our understanding of how e-commerce websites work allows us to produce basic operations such as selling items, buying items, registering user accounts, and utilizing payment methods. Model View Controller MVC architecture was our desired design pattern that enabled efficient development of our website that was robust and easily maintained. Once underlying principles of e-commerce systems were established, our e-commerce websites began with a business model that dealt with the typical user transactions and database operations that would later become our web services. Our view would later entail designing user interfaces that dealt with displaying information from the database and dealing with users' interactions such as registering accounts, uploading, selling, and or buying items. Our controller would use our web services to manipulate data in our databases if user actions occurred. Overall, e-commerce websites enables a safe and efficient marketplace for ASU students to exchange goods.
Here is an overview of our design pattern. As you can see, we have a model, view, and a controller. The user would be using the view side and would be interacting with the website on that end. And all the interactions of the user would then update the controller. The controller would then update the view and also the model, which in turn would update the controller, which in turn would update the view.
So this is what our project looks like in a general overview. We have a database that stores all the informations, and those informations can only interact through web services. The idea behind this is to allow other users to be able to contribute to our database without changing the format or constraints intended. If a user wants to look up for a product, they will need to consume the web service. The web service will send data, for instance a product ID, to the database, query the results, and return them as a service as well. This ensures security, as authentications are needed to call the web service. Authentication or credentials to call a web service can be obtained by registering through the Registration for Services. Our sponsor wants only ASU students to be able to register for the web service. As a result, we make the user only able to register using their ASU email address, and the credentials will be sent to them via ASU email. This is an example of our website which is currently in development. It does not represent the final product as we have not implemented CSS and other stuff that are needed. For user story, this is a very good example of how the web services works for our website. So user will key in all the information in the text box, and upon submit, all the data will be sent to the database as a web service. Before actually writing or storing those data, our server will check for all the constraints such as if the ISBN number are integers, remove any delimiters or white spaces if there is any, and as we all know, ISBN number is a 13-digit character, so it will check if it's of length 13 characters. It is a precise step-by-step procedure, and this is done for every input for the entire website. Once every input meets the database constraint, it will write those information into the database. Once it is complete, it will return a true or false as a result to notify the user who is consuming the web service, so they will know what to do next, such as maybe have a message box saying, "Books have successfully been updated."
The timeline for our project began on October 7th by considering various designs and layouts for our database and our website. We also discussed security control implementations for the UIs of our sign-in and sign-up pages. Since our project was to be centered on a service-oriented website, we had to consider the various services we would need to create, as well as the specific details of the site itself, such as what types of products would be sold, etc. Once we had come to a decision on the design of the database, we began the creation process. The user interfaces on our site would need listings, and the information from these listings would need to be connected and stored accordingly into the database. After that, we began considering the implementation of an MVC architecture. This led us to discuss overall security of our project, including the user login and password protection, which we elected to secure with hashing and salting. Next, we created a UI for our search functions and payment transactions. We also began creating the query functions for the database and implemented the aforementioned password encryption functions. After that, we created working user input for the listings and functions to generate unique IDs for both users and products so that the database could be queried accordingly. In discussing the design pattern for the project, we finally came to the decision to use MVC5. Prototypes were then made for accepting user payments and searching for products so that we could implement them later. Lastly, we created the user account signup functionality and began considering how to upload images for products.
Our future plans include implementing steps to protect against database SQL injections. We will try to obtain an HTTPS certificate if possible so we could test our site using encryption. We know that this is a paid service, so in the future we might have to pay for this service. If we can obtain an HTTPS certificate, all communication between our browser and our website would be encrypted. We would need to improve our user experience by adding more functionality on the user end. We would also need to enable our website to be displayed for mobile devices, which would have to include some JavaScript like Bootstrap. We would also have to implement a terms and conditions document. That's all for now for our website.
Thank you for watching our presentation.